any probability question is related to the area. So what I mean is, if I asked, what's the probability I have to wait in between 7 and 9 minutes? Can you guys draw that on the picture? No? Somebody's like, ain't no way I can do that. 7 to 9. Can you draw that? Where's 7? Give me a rough. 7's about right there. Where's 9? About right there. Sure. What the hell? Doesn't matter. Right? Is that? Do you guys see that? Yeah. The answer would be the area of this if the area of the whole thing was 1. The area of the whole thing being 1 is like adding the probabilities to get 1. If the whole thing is 1, that means all the probabilities make 1. And then any sub piece of it, like the dartboard with the bullseye, the probability of that is going to equal the area of that. So how long is this?
16.
Try it. I love it. You're thinking about the earlier thing.
50.
It's 15. Yeah. So just mathematically, there's 15 here, right? You guys with me? So how tall would it have to be to make the area 1? What do you multiply by to make something 1? You multiply by its reciprocal. So how tall would it be? Yeah, what's 15 times 1 over 15? 1. Kick ass. So I know the answer to this question now. What's the area of this rectangle? I mean, do you see how we've made this into a beautiful, geometric, easy-ass problem? So if I can graph a probability distribution and I make sure the whole area is 1, any probability question in that situation is easy as shit if the geometric shape it makes is easy, right? So here I got frickin' rectangles. It's hard to be easier than that. So what is the area of this rectangle? How wide is it? 2. How tall is it? 115. So it'll be 2 times 1 over 15. And then whatever the hell that is. 0.13 something? Yeah? What is it? 1333? Neato. Yeah, that's pretty good. All right. Now, just to make sure you guys really get this, well, you're all like, we don't get this shit yet. You done one example. Okay, let's do another example. What about a uniform distribution where it was anywhere from 4 to 11, right? 4 to 11 whatevers. Can you tell me what the height has to be to make it this valid?
111.
No. Yes. Again, how wide is this? 7. So be careful. I wanted to do another example where there wasn't a 0. Why was this 15? Because that was 0 to 15. Well, this is 4 to 11. That's 7. So it's got to be 1/7. Now the area of that box is 1. Right? So what would be the probability that I get in between 6 and 10? All you have to do now is draw that in and see what the area is. It's almost too nice to trust that that's all it is. Maybe, I don't know, you guys. So here's 6, here's 10. What's the area of this? Yeah, because it's 4 times 1/7. 4 over 7, which is 0.5714. I've almost got the divided by 7 memorized. And you're all like, whatever you want to do with your free time, Jeff. I love it. That's what I do for fun. Get me some rum and just memorize divided by 7. Okay. So, look at the back of this. And by the way, real quick, I want you to realize 2 things before we look at the back. I got to do this. I just want to show you this example. It is possible to have a distribution that looks like this. Remarkably enough, we call that a triangular distribution. Holy shit. You guys don't, and we're not going to do these problems, right? But still, just sit there and absorb this. So if I wanted to know the probability that x was greater than 4, right? Let's do it right here. All I have to do is know what the height of this is. I could figure out the area of this, right? You guys with me? What's the area of a triangle? What's the formula? 1/2 height times base. Kick ass, right? So again, I just want to show you another example that's not a rectangle, that if I drew a probability distribution and the shape was something I knew the geometric area formula for, I could do that. And it's equal to the probability, right? So area equals probability if I make the whole area 1. So if I have a shape like this, well, of course, what shape is this? Normal curve. If I want to know the area from here to here, why does that suck? Because one side of this has melted or something, right? Do you have a geometric formula for melted rectangle? If you do, I want to freaking go to that your geometry class, whatever you took. Do you guys understand what I'm saying? Can I find the area of this using geometry? No, I cannot, because that side is curved. Unless you have taken calculus, you cannot do that. And if you have taken calculus, woo, it's not going to help you. Don't worry. If you haven't taken calculus, you're not at a disadvantage. But if you have taken calculus, the thing called integral is what they would do. So let's not worry about this yet. Later, this is going to be in our future, but thankfully, I'm going to give you a sheet that has all the area answers on it. You just have to know how to use it to find them. So we have a sheet that calculus people made for us on a computer that has all the areas, right? I like it. Okay, so look at the back. Look at the very last problem. Try to draw that distribution. And don't forget to show the height. So when I say draw that distribution for a uniform, you got to show me the box, you got to show me what it goes from to, and you got to show me the height. So just do part A there. Is interesting. For some reason, it always takes me at least a minute to find them damn car keys. Sometimes up to 12. Is this true? I don't know. It's uniform, so I know it looks like this. The same way if I said it was normal, you know it looks like that. How tall must it be? 1/11. The height will always be the reciprocal of the base, because the only way two numbers can multiply to be 1 is if they are reciprocals of each other. You actually came to this class knowing that. It's just that you don't use that fact very often. Maybe. So now I can answer, of course I've drawn through this. What the hell does this say? 7? Thank you. Between 7 and 11 minutes. So that one mistake, watch, this is a mistake. I always get somebody to do this. They just remade reality. No, you can't remake it, I'm sorry. You gotta live within reality. Here's reality. Draw this situation in there and then figure out that area. That'll be the probability, right? So if I redraw this, woo, I want to go from 7 to 11. And then you just have to find that area. It seems almost too nice to believe, especially after some of the shit I put you through. You're like, that can't be it. Fortunately for you, there's only 2 sections in this easy-ass chapter, but oh, that's too bad. Please let this be easy. Hopefully the concept is a little bit weird, but it's exactly the same. We just intuitively know this. A dartboard. Of course you get more points for that because it's hard to do that. You must be talented because it's related to the area and it's a tiny little thing. We know this. We're just making it more formal now. So what is this probability? What's the area of this? Yeah, it's 4 times 1 over 11. So 4 11ths, 3 6 3 6 3 6 3 6. Is that cool? Okay. All right, what about, now you guys try part C. Gotta be a little bit careful here. Gotta live within reality, and that's reality right there. So the first 5 minutes, what's the probability? What am I drinking? What is the probability that it takes me less than a minute? 0. I love it. It's impossible. So the first 5 minutes, where does that show up in the distribution from 1 to 5? Good. The first 5 minutes just includes some of this impossible shit. So then again, it's going to be the same answer we just got, right? Because what's the area of this rectangle? 4 11ths. 3 6 3 6. All right, maybe. What's probably takes me more than 12 minutes? 0. I love it. Yes. Because what's the probability do after there? It just drops to nothing. So what's probably, now here's the really neat question. Okay, this is the last thing we'll do. What is the probability it takes me exactly 8 minutes? Nope. The answer to these questions is always related to the area. What is the area of a line? Because if you draw in equals to 8, what's that look like? Here's 8. There it is. What's the area of that line? It's not going from 8 to 9. That would be 1/11, because then it'd be 1 times 1/11. What's the width of a line? 0. Kick ass. And that seems so weird, doesn't it? But go with me for a second. I want to say a couple things. How many numbers are there from 1 to 12? How many numbers are from 1 to 12? How many numbers? Meaning, count 1.222222227, 1.222222228. Also count 7.03946666665. How many numbers are from 1 to 12? Infinite number. I love it. You with me? So what would go on the bottom of a probability? Infinity. And I want 1 of them. So that's a 0 chance. You guys semi with me at all? So really, if you don't like what I just said, it is exactly the area, and the area of a line is 0. All right. The second thing I want to say, in case anyone is interested at all in this, and you're all like, dude, just tell me exactly what I got to know. Right? There's an idea called iota. Anybody ever heard the word iota? Some of you guys, maybe you have an iota's chance. Iota is sort of like, it's not this exactly, so math people just shut up. But this is basically the way you can think about it. It's the smallest positive number. If you think about that for a second, what's the smallest positive number? If you think you found it like 0.000001, we'll cut that in half, and then cut that in half, and then cut that in half. So it's sort of like infinity doesn't stop growing. Iota is sort of like the opposite of infinity. It just gets as close as possible to 0. All right, and that's, I'm sorry, I said too much of that, because we don't have to worry about iota at all in this class. You with me? I just wanted to throw that out there, just in case anybody's at all curious. Otherwise, that's enough. So I'll see you next week. I think, right? What is it? Thursday? I'll see you Thursday. What is today? Tuesday. See you Thursday.
We can say that it's Thursday. Come on.
As long as you come back, whatever day you would call Thursday.